Okay, today we start the necessity of motion. Newton had this notion about motion, and in comes calculus, and that's how calculus became developed. It's primarily because of motion, and that's its initial thing. Then everything else kind of developed from there. Anything that changes over time, calculus is relatively necessary. Um, let's first understand that we're talking about motion, and we're talking about motion and what we call rectilinear motion. That means it's falling on a number line. So if I have a simple example, if I travel from 1 to 7, I've traveled a total of 6 units. Well, that's just a simple understanding of displacement. It's the beginning position. I apologize. End position minus start position. I want to oversimplify that because we know it's 7 subtract 1 is 6, but we want to make sure we understand it's the end and start position. You can have negative displacement. That just basically means you, over the period of travel, you've gone, you've lost ground, put it that way. Now, total distance travel is not the same thing, and I'll do that and illustrate that in green. Uh, Total distance traveled, I can get the same kind of displacement. I can go from 1 to 7, get a total of a position of 6, but my total distance travel could be totally different, especially if my wife's in the car. Like we can get as far as position 3, and then she says, "Oh, I forgot my purse." So then I travel backwards. Notice I'm doing this all on a number line. It's rectilinear, meaning I'm not motion in 2 dimensions. And then so we start at 1, we move to 3, then we go back to 1, and then we travel to 7. Now in this case we have a displacement of 6, but now my total distance traveled is totally different. What to emphasize here is we created 2 positions of stop. We stopped here and we stopped here. Okay. Once you've established your stop, you determine distances to those stops. So my first start to finish is from 3 to 1, which is 2. Then I add my next movement. Even though this is a negative direction, I'm considering it a positive distance. So everything here in total distance travel must be positive. So I move from 3 to 1, which is a total distance travel of 2. Then I won't move from 1 to 7, which is 6, giving me a total distance traveled of 10. Notice that's not the same as my displacement, and it most cases will not be. The reason again is because we got to emphasize the stops. Start, stop, stop, end. So we have to measure the distances to each one of those. Average velocity is not something new. We've already discussed this. It's average. It is slope. It is calculated. It is virtually just slope. It should change in your position over change in time. Okay. Just because I traveled an average of 50 miles an hour does not mean I was going 50 miles per hour the whole time. My speed can vary. So basically, you just take your change in position and divide by time. Instantaneous velocity is no different than instant rate. This is a rate. So it's instantaneous rate or the derivative. Uh, this is a better notation here, ds over dt. Notice it very connected to that. It also allows me to say I'm taking the change in my position and I'm taking its derivative with respect to t. It comes up later. It's a significant piece. Um, acceleration. Now, acceleration is the derivative of your velocity or the double derivative of your position. The way we would write that in that better notation is second derivative of position with respect to time twice. So it's d squared s over dt squared. That simply means take the derivative twice. It doesn't mean take your derivative and then square that. It means take the derivative twice. It's unique notation. Now velocities, these velocities here instantaneous velocity and average velocities can be negative. If you're heading in a negative direction, you have a negative velocity because you're losing position. Um, so when we talk about motion, we generally don't say my speed is -5 miles per hour. Generally, we make that positive. So in comes the need for the absolute value. So speed is simply the absolute value of your velocity function. Free fall gravity, this is just in case the questions come up. They will give these on the AP test. If you need those units, that is acceleration. In a sense, what happened is Newton came up with these numbers first. I don't know whether, I'm sure it wasn't feet, probably wasn't meters either, but he had a units for gravity. He determined that was the rate. From that, he was able to backwards go into from acceleration to velocity to positions. And we'll see that later as we learn more. Right now, we're only learning derivatives. We have to learn how to undo those things. So this section here is just the beginning of an FRQ for later on. Other applications, marginal cost is a big term in business. So if any of you guys go into business, marginal cost is just simply the derivative or the rate of my cost, and marginal revenue is the derivative of revenue. It kind of tells you how fast your revenues are going up or down. What's interesting about those two is if you take your marginal cost and you set it equal to your marginal revenue, whatever solution you get there, it's where you're going to maximize your profit. You know, people always say, well, the more I sell, the more I make. That's not always true. Sometimes you want to taper off how much you make, and in return, you get better profits and you make more money. If you could turn to page 131, and this will be me pausing for you to get that book open, or just hit the pause button. Going to go through a series of questions. Given a polynomial function, a lot of these will be polynomial to begin with for you. So I'm going to start with this one. Sorry, I put Y. I don't know why they use S for position. Don't ask. I don't know. It's considered a number line, so sometimes instead of S, they use X. Helps you visualize it's on the X line, but they can also use Y. It's not relevant. Now the example they have is, there's your position function. It allows me to find my position at any given time. And note, they have comments like t is greater than or equals 0, only because it doesn't make sense to talk about negative time. That would be a go. So position. The first question is, find the displacement of the particle in the first 2 seconds. Now, displacement requires me to have my start position and my end position. So part A to the question, I need my end position, and that would be at time 2. So S2 is my position. And my start position, I need those two things for displacement, which I started at time 0, even though the words didn't imply that. So my displacement equals S2 minus S0, which in this case will be 2 squared subtract 4 plus 3. Let's see, that's minus -1 minus my end position is 3, giving me my displacement of -4. And if there's units, you must consider the units here. It is in meters. So I have a -4 meters displacement. That only means I move backwards. B. Dice, find the average particle, the velocity of the particle during the first 4 seconds. So what I need to do is I need my change in my S over change in my time. After the first 4 seconds implies I'm going to start with my end time position minus that, my beginning, and then 4 subtract 0. And then you can compute that. If you compute that, you get a lovely answer of exactly 0 meters per second. Now, how the hell does that make any sense? How can you have 0 miles per second, meters per second? Well, that's an average. This must mean we went forward and then we went backwards, and overall, I basically have 0 velocity to averaged. It's very simple. You got to understand, we have negative velocities, hence we wind up with these averages that can be 0. C, say find the instantaneous velocity at 4. Instantaneous is the derivative with respect to time. Well, we got to take that derivative first. So 2t minus 4 took its derivative. So my position, my change in my position over time at, so you notice I drew the line, that's how they do it in big boy world, at time 4 is equal to 2 times 4, subtract 4, which is 4. So apparently I was traveling at 4 meters per second on the 4th second. D. D says find the acceleration. Okay, well, acceleration, AT, is the derivative of my velocity, or it's my second derivative of position with respect to time twice, which comes out to be 2. So if I took that derivative, I get 2. There is no value, so it doesn't matter at any given time. If this particular question says find the acceleration at time 4, it doesn't matter what time because there's no variable in my acceleration. So my answer is 2 meters per second squared. Again, note the units make sense. I'm taking the derivative with respect to time twice. Your units are s over t squared. See that? All right, E. E. Describe the motion of the particle. At what values of t does the particle change directions? Well, in order for me to determine time that it changed directions, I need to have where it stops. Well, where it stops is where the velocity is equal to 0. So we're going to get, first we have our initial position. So we're going to know that. We already have that value to be 3. That's our original function. Now what I need is my position for each time it stops. But we have to find that first. Well, it stops when the velocity equals 0. That is stop. So I'm going to take the derivative, which was, let's check it out, 2t minus 4 equals 0. So the only time this particle stops is at time 2. So my position at time 2 is, let's figure that out real quick, plug that into my original function, because before I already have that value, it happens to be negative 4. So far, what I've gotten is that my initial position was 3. My now stop position is negative 4. That means I've traveled a total of distance of 7. Okay, then now I need my end position. Since it only stopped once, I need my end position. There is no end position established here. So basically, here's what I've got. I'm going to consider the rectilinear motion. Put myself a nice, beautiful little number line. I need a 3. I'm going to put a negative 4 on here. So here's what happens. I started at position 3. I traveled to negative 4. So I'm moving right. Interesting thing about that, pick any number. So here's my start, here's my stop, and I have no end, and it keeps going in the positive direction. Here's what I want you to do, is pick a velocity between start time, so it starts, and then we have a stop at 2. Pick a value in between. So I'm going to pick t as 1. Check your velocity out. Velocity at 1 is 2 2 times 1 subtract 4 is negative 2. Notice that makes a whole lot of sense because anywhere initially between time 0 and time 2, I'm moving in a negative direction. Now let's pick a time after 2, like t is 3. At t is 3, my velocity, which gives me my direction, it tells me if I'm heading in the positive or negative direction, I get 2 times 3 subtract 4, which is positive 2. Notice I'm heading a positive direction. Yes, any value of t I picked over 2 will be a positive number. That's why we're going in this direction. So basically I just drew this number line is in fact a description of your motion. F on that section, we're not going to worry about F. Okay, now let's move to the back. I got one more additional example that may shed some light here. Okay, so they give me a position curve, a position function, and they give me a time. Now they're going to ask me a series of questions. Keyword, instantaneous velocity, which is my derivative. And they just want a at any time, t. Well, if I take the velocity, take its derivative, I get negative 4t cubed plus 12t squared. Now we're going to love factored form right now. My velocity is this meters per second at any given time. Acceleration would be the derivative of that. And those units would be measured in meters per second squared. Rest. Rest implies it's stopped. Where's the particle at rest? That means when did it stop? Oh, that occurs. So the word rest implies when is your velocity equal to 0? Well, let's set that velocity to 0. See, here we go. Now I'm really loving factored form. So I have this function, velocity, which is right up there. I'm going to factor out, I don't know, let's just factor out negative 4t squared. It gives me t minus 3. Now I'm going to set that equal to 0. So what it tells me is the particle was at rest, or whatever motion's happening, occurs when negative 4t squared equals 0. I'm setting each factor equal to that 0. Wow, that does not look like a 2. My goodness gracious. There we go. If you solve that, you get t is at time 0. So at time 0, and when I initially started, this thing was stopped. But I also noticed that it stopped at time 3. So it's at rest or stopped at 3 seconds and at 0 seconds, or basic at the beginning. When is the particle moving left or right? Well, if it's not stopped, it's moving. And it's rectilinear, so it's only moving either one direction or another. So what I'm going to do is I'm going to say, okay, at time 0, we have a stop. At time 3, we have a stop, which means in between that time, any value in here, let's just say t is 1, I'm going to check the velocity, because velocity will tell me my direction. Velocity at 1, where the heck is velocity? I love factored form. I'm going to get the velocity in a vector in a factored form. So if I plug in t, I get negative 1t squared, 1 subtract 3. I really don't need to know exactly what the number is, but when I plug in 1, I get negative times a negative, which is positive. So this is going to be a positive number. I really don't care what it is. I just know it's positive, which tells me it's moving in the positive direction or moving right. Now I'll pick a number over here after it stopped at time 3, and let's see which direction. Just because it was moving right and then it stops does not mean it has to move left. It could continue to move to the right. We just don't know. So I'm going to pick a number like 4, and I'm going to plug in 4 into my velocity. Again, I like the factored form because I can determine the values quickly. So if I take 4 and I square it's positive times a negative 4 is negative. And the 4 subtract 3 is positive. So I have negative times a positive, which is less than 0. That means it's got to be moving in the left direction. Now this is new, and you want to put this in your flashcard right here. This is the part why I'm choosing this topic. Speeding up and slowing down. I mean, I might pull one of you out in class and kind of show you what the heck I mean by speeding up and slowing. If I'm moving in a positive direction, and I'm deaccelerating. It means I have a negative acceleration. It totally makes sense that if I'm going in a positive direction, my velocity is positive, and my acceleration is negative. That means I'm slowing down. However, if I'm in a positive direction and I'm accelerating in a positive, then I'm probably speeding up. What's confusing is, what if I'm moving in the negative direction? And this is where a visual would help. We'll probably do it in class. But if I have a negative velocity and my acceleration pushes me more negative, that implies if both my velocity and my acceleration are both negative, I'm in fact speeding up in a negative direction. However, if I'm moving it in a negative direction, my velocity is negative, and I have a positive acceleration, now my acceleration is slowing me down in a negative direction. So now I can, basically those two terms. Point is, in order to determine speeding up and slowing down, point being, is you need to know the velocity and the acceleration values. For speeding up, I can have a VT greater than 0, acceleration greater than 0, so they have to both be positive, or I can have a VT negative or acceleration negative. That means double negative means I'm speeding up in a negative direction. Where slowing down is just the opposite. So you're going to have a VT positive and an acceleration negative, or VT negative and acceleration positive. Anytime the signs of the velocity and acceleration are different, you get a slowdown. Okay, so in this particular case, let me erase this. What I'm going to do is I'm going to apply this now. Make sure that is a flashcard. It's a very common misunderstanding about speeding up and slowing down. Is when you're heading in a negative direction. Okay, so what I'm going to do is first of all, we need to know where the velocity stops, where it starts and ends. So we know it only stopped at t is 3. That's where VT was 0. But we're also going to need to know where acceleration changes its push. Acceleration is like a push. Okay, so what I'm going to do is I'm going to set my acceleration equals 0. Now I got to figure out where my acceleration was. Ooh, there it is. Negative 12 t squared plus 24 t equals 0. Again, I love factor form, so I'm going to factor out negative 12t. And that means that t is 0. Again, that's not going to be relevant because that's actually my starting point. And then the other one is t is 2. So this is a key element, and that's a key element to where things change. So what I'm going to do now is I'm going to think about my timeline. Started at 0. The next time something happens, it's 2, and then at 3. And what I'm going to do is consider values between those to see if the positive. So between time 0 and 2, let's look at its velocity and its acceleration. So if I pick time as 1, I plug in velocity. If I plug in 1 into my velocity, which I've already done, I get a positive number. Now if I take acceleration and plug it in over here, and I love factored form. Here's my acceleration in factored form. If I plug in 1, I get 12 times a positive times a negative, which is positive. Since both of those signs are definitely in the same direction, I'm speeding up, wow, I spelled that wrong, up between 0 and 2. And let's see what happens between 2 and 3. Pick 2.5. I plug it in up here. I'm going to get a negative times a positive times a negative, which is still positive. My velocity is still positive. But now if I come over here to acceleration and plug it in, I get a negative times a positive, which is negative. Now I've got different signs for those two. So that tells me I'm slowing down between 2 and 3. Now let's do our final section. Let's do it. So I picked 2.5 here. I'm going to pick 4 over here. If I pick 4 and plug it into my velocity, which again is way up here, if I plug it in there, I get a negative times a positive, which is negative. And then my acceleration is down here. I plug in 4, I get negative times a positive is negative. Now I've got two signs that are both negative, which means it's now speeding up in the negative direction. So my speed up is from 0 to 2, 3 to God's land, to infinity, and my slow down is from 2 to 3. So once we have all this, describing the particle motion is relatively straightforward. It can be done on a number line. We did it, I think I erased it, but it doesn't really matter. We start off at time 0, and the particle moves to position, where does it stop at? It stops at time 3, and I don't have the position there for time 3. Okay, but we're going to do that. We're going to plug in T3, so it moves in the positive direction till T3, and then we find its position, wherever that is, and then it moves backwards after T3. So this would be my position line. The only thing I want is two things. I want to know my start position and this position here, which would be at time 3. The rest of the time it's moving left to right. Total distance traveled. Again, it's not going to be the same as displacement. I need my start position, which is T0, and I guess I'm going to have to plug that in now. S0 is, if I plug that in, I get 0. I need my stop position, which was at time 3, I believe. Yep, time 3 I stopped. At time 3, now I'm going to have to do some magically delicious math in my head. I'm now doing it in my head. I would never cheat or anything like that. I got -4 times 27 plus 12 times 9, which indubitably is 8. -108 plus 98, which of course is clearly -10. So I start at, now I'm at, so at time 3, I'm at the position -10. So far I've traveled a total distance of 10. Now I need T4, that's the stop position, or its ending position. So I got my start, my stop, I only had one, and then I have my end. So S4, oh my God, I gotta do math again. Okay, so 4 cubed is 64, 64 times 4 is, I don't know, could do this in my head faster. 6, 1, 256, -56, plus 4 squared is 16, my favorite game ever. 16 times 12 is, 192. Which means I'm at position -64. I think I've done something incorrect. Lord knows what, because that doesn't make any sense. But okay, so -64. Doesn't make sense because it's supposed to change directions. And I should have had a positive number here for S3. So let me just check S3 real quick again. -4 times 3 squared, 3 cubed, -4 times 27 is 108, -108, plus, what do I got wrong here? 4 times, oh, that's what I did wrong. I did it wrong twice. You're a ding-dong. It should be to the 4th. Sorry. Let's start those values over again real quick. So I actually get it right this time. So this number right here, I apologize, this number right here should have been 27. So I started at position 0. Now I'm at 27. That makes more sense because I was going in a positive direction. And position at 4. Wow, that was way, so it's 0. So my total distance traveled, I traveled 27 here, 27 here. So my total distance traveled is 54 meters. Okay, begin your book work. Again, I'll probably do something in class with